Okay, so first of all, how many has been able to set up the basic lab? Because in this training, definitely we want everyone to do hands-on. Without that, it will be very difficult. So for all the new folks for whom I shared the meeting very on a short notice, I'll share you the uh, how to set up your lab on ATD later. But for the remaining people, can everyone confirm if everyone has able to set up the lab, or at least if anyone has been able to set up the lab, or no one did?
Need to spin up the lab.
Yeah, I didn't get a
I'll
chance.
do it today though.
Okay. No, it was a bit of a short notice also because I understand if you're not able to do it, but let's try to finish it by today. It won't take a lot of time. So today we will start off with EVPN L2 multicast, and the assumption is that everyone here is aware of regular PIM and IGMP. Okay, so this is the setup I have in the lab, which we'll see shortly. So I have these two independent leaf and these two hosts in the same VLAN, and I have a spine. So before I move,
a small request, can we record this session, Aniket?
Yeah, we are recording this.
Okay, thank you. Sorry, I didn't see.
No worries. So before we deep dive into EVPN multicast, can anyone say how before EVPN multicast how we used to deploy multicast in VXLAN Fabric? And let's this is not like a training as such. This is more of a discussion. You can think of it, because initially we planned this as a discussion, not a training. So it is still a discussion. Okay, so feel free to pitch in and share your thoughts. Okay. So can anyone tell how it used to work before EVPN multicast, how it evolved and reached EVPN multicast in AVXLAN Fabric?
We used to flood the traffic, right?
Yeah. Right. So earlier, let's say, yeah, sorry, go on.
No, I was just answering your question. So we used to enable a PIM between the leaf and the spines, and they used to build that PIM relationship with each other. And for the across the VXLAN, they used to flood the traffic.
Yeah. So if we talk about flood, right, then there was no PIM on the underlay. Okay. So if you receive any multicast traffic, and when I'm saying multicast traffic, I don't mean link local, just regular multicast traffic. If you receive that, then this device is just a layer 2 switch. This is not capable of, I mean, we never used to do multicast routing or anything. So any multicast traffic that will receive will just, based on the flood list, will flood it. And it will be reached to all the VTEPs. So in that case, there was no need for PIM here, because it was just working like any flooded traffic, like broadcast or unknown unicast, right? So later we came up with another solution where we could configure PIM here, and whatever traffic that you receive. So that used to work in conjunction with VXLAN, but it was not a VXLAN encapsulated solution. Like, it was not a VXLAN tunnels based solution. So any traffic that you will receive based on PIM, in the underlay you will be running PIM. So based on the M routes and everything, your traffic will be routed and going to spine, and from spine to this leaf. So that was not VXLAN encapped again, but it used to work with VXLAN as well. Okay, so
regular multicasting.
Regular multicast, you can think of this underlay as a PIM domain. Okay, and just like how regular multicast works, it used to work. And there were some other concepts which I will not go into the depth of that, but we had address family multicast where we could advertise once we discover the source. Let's say this was a FHR. Once the source is discovered, we will create a /32 route for it, and we'll send it to the LHR. So that, and that used to be come under address family multicast, so that you have a route in the MFIP for RPF check. So that was a feature that was added, and but yeah, that is now obsolete, you can say. I don't think anyone uses that nowadays. So this is where we came up with EVPN L2 multicast solution. I think in 4.25 it was introduced or so. Let me just check. Yeah, 426.0. Okay. And can anyone tell what is different here? What has changed? What, at least you don't have to talk about the the underlying details, but what is different here?
There is encapsulation of the.
Yeah, about the encapsulation and all. Can
Now we
so
perform
earlier,
the make a proper underlay tree, right?
military, okay. So underlay PIM based tree,
Underlay
right?
pin tree, yeah.
Okay, and
Because no
we
flooding
have,
would be there, of course.
so yeah, so now there is no flooding for multicast traffic. Okay, there is no flooding. It is, everything is based on your underlay PIM tree and the snooping that table that you have. Okay, so now we have to understand one thing here. What is different from previous models is that in previous model we never had PIM on this uplinks. Okay, so we never configured PIM on these interfaces when it used to work just with flooding. But with EVPN L2 multicast, we are going to configure PIM here. Okay, so this is going to be a PIM enabled interfaces. I'm going bit fast here, assuming that these are very basic. So yeah, so you would enable PIM here on these interfaces, right? Why do we need a PIM here?
To build the underlying.
For,
Yeah, so as mentioned here, we need to build the underlay PIM tree, right? Yeah, sorry, Naveen.
no, I was saying the same for underlay PIM tree.
Yeah, because now we are not going to flood anything. We are the encapsulation, after the encapsulation, the traffic is again going to be routed based on M route, which is in the default verb. Okay, so for that you need underlay PIM tree, right? And again, in this you have only 2 leaves, but of course you can have multiple leaves here and multiple spines. So everything will form a PIM tree here. Now, some additional. Now, one thing is to note here, right? When you have a receiver, when it sends the IGMP join, okay, IGMP report. Let's say it's a V2 report only. So in we never used to flood this report unless you disable snooping for report. You will never flood this report. So now in this case also, when this receiver is sending a IGMP report, we will not flood this report. But this sender needs to be aware that there is a receiver that is connected, right? So can anyone tell how we do that? What is the signaling?
So we use something called SMET route, type 6 route. So whenever leaf 4 receives an IGMP report, it will signal the remote source, VTEP, that I have an interested receiver behind me, and it's via the type 6 route.
Right. So now this is something that everyone should remember, that this SMET route is you can say this is a IGMP report in EVPN. Okay. So whenever you will receive IGMP report for a particular group, you will generate a EVPN SMET on the LHR. Right. So as soon as you will send the IGMP report, this device will snoop that report and it will generate a EVPN SMET route, which is a EVPN type 6 route. Okay. Now this is how this leaf is going to know. Leaf 1 is going to know that there is an interested receiver behind a remote VTEP. Okay. Now we'll see all these things in the lab later, but I'm just talking in a very high level. So what happens next? Once this estimate is sent, what are the steps or what are the operations that will happen on leaf 4? So let's just talk about leaf 4. So when leaf 4 receive the IGMP report, it generates a EVPN estimate route. What other things will happen? Can anyone think of it?
It also has to initiate a join.
Initiate a join.
Sir.
Okay, initiate a join for?
Send a SG join to construct the underlay tree.
Send SG join to construct. Now there might be a lot of questions here. What is this underlay tree, right? What is this join that you are sending, right? So when we configure EVPN multicast, so there are some very base level configuration that we should know. Okay, so in this leaf under interface VXLAN1, other than the regular configs that you know, the VXLAN, VLAN 100, VNI, let's say, we will also configure a multicast group. So let's say that is 225.1.1.1. Okay. So when we do that, this device, this VTEP, it will create something called as EVPN SFMSE AD route. Okay, which is a type 10 route. This is a way of this leaf saying to other VTEPs that, hey, if I receive any feed from this host 1, I'm going to encapsulate this feed with the outer DIPS 225.1.1.1. Okay, so this leaf 1 is always going to, for any multicast traffic that it will receive in VLAN 100 from host, it'll always encapsulate with the outer DIPS 225.1.1.1. And what will be the outer source IP?
VTEP IP.
Outer source IP will be the VTEP IP, which is, let's say, 111 of leaf 1. Right? Now you need to understand that this leaf, because it's all PIM, right? This leaf is only going to send the traffic towards the spine if the spine is going to send a join for this group. And the spine will send the join if this leaf 4 first sends a join for this group. Okay, so this leaf, this leaf 4, whenever, as soon as it receives the IGMP report from the receiver, okay, it will do two things. It will create a EVPN estimate route, which is a way of saying that I have a receiver, and it will use the EVPN type 10 route that it has received from leaf 1. Okay, and I'll show you how the route looks like and everything. It will receive the as soon as you give this command, it will advertise its SFMSA type 10 route, and leaf 4 is going to send a SG join. Okay, because the route towards 111 is pointing towards the spine, so it's going to send a SG join towards spine. Okay, so if you do show IP mroute on leaf 4, you will see that this is the mroute. You will see that for 225.1.1.1, you have a source which is 1111, and for that the IF is, what will be the IF?
The underlying interface? Or
underlying interface, right? So that will be Ethernet 1, let's say. So this is Ethernet 1, this port, and the OIL will be your VLAN 100.
Question, and if the config for multicast group, that VXLAN multicast group, is that present only on leaves where the source is present or everywhere?
Well, ideally you should configure everywhere, because we don't know, source could be connected anywhere. But in this scenario, like I have the source only here, so only this leaf is going to encapsulate. So I just gave it here. But we can configure everywhere, and whenever you configure, every leaf is going to advertise the type 10 route. Okay.
And this
but
multicast group IP should be unique in
no,
each leaf.
it doesn't have to be unique. So here also we can give the same command, VXLAN VLAN 100 multicast group 225.1.1.1. But it is unique. How it is unique? because remember it's a SG. So here the SG is, the source is 4444. Okay, here the source is 1111. This is how it is unique.
Okay.
Okay, so now let's say you have a receiver behind leaf 4, then this leaf 1 will join the SG of 225.111.4444 to receive the traffic from leaf 4. Okay, so there are two things that is happening. One is it creates a SMET route, because if you don't, if this, when this SMET route is sent to this leaf 1, only then this leaf 1 is going to encapsulate. Only then you will see this leaf 1 will know that there is a remote receiver. Only then it is going to encapsulate. Otherwise, it will not encapsulate. So this is why this SMET route is important. Okay, and this leaf 4 is going to join the underlay tree for 225.111, 1111. So it's going to send a SG join to the spine. The spine is going to send the SG join to this leaf. Okay. So once this tree is underlay tree is formed, okay, once you have the OIL, let me just create the. So you'll have the SG here, which is 225. So your IF will be your loopback, which is your VXLAN loopback here. And that is because you can think of it as like you're receiving the traffic which is going to get encapsulated. Whenever that happens, the IF is loopback 1. And the OIL is going to be the uplink to spine, which is like Ethernet 1 or 2. Okay, this is going to be the uplink for this SG. Once this is done, and in your snooping table, you will see that there's something called as PIM tunnel. So when it receives the SMET route, we will see if you do show IP IGMP snooping group for, let's say, VLAN 100, you will see for like star for any source, and the group will be the overlay group to 10.111. Okay, you will see PIM tunnel, which will be populated based on the SMET route. And we'll see how the SMET route looks like and everything, then it will be more clear. But the point here is that when it gets the SMET route, then this PIM tunnel will be created, and only then it can encapsulate. Once the encapsulation is done, then it will refer to this M route to send the encapsulated traffic out. And on this spine, you will have a M route, similar M route, with IF as this interface and the OIL as this interface. Okay, so let me show you in lab, then I think it'll be becoming more clear. So
I have one doubt. I'm not sure this will be covered later. The source IP and the like sender IP and receiver IP are same, right? Like are in same subnet. So when leaf 4 wants to do a RPF check, then the incoming interface will change to VLAN.
There is no so this is just a layer 2 switch, right? Here the RPF check will happen for when you receive the feed on this. I mean, for the encapsulated feed.
Okay.
Once it is decapsulated, then it will just look into the snooping table and it will send the traffic out.
Okay, understood.
So it will get the encapsulated feed, and then it will do RPF check when it receives on the PIM-enabled interface.
Okay.
The VNI will be 100, and in this snooping table for VLAN 100, there will be entry for this receiver, so traffic will be going out.
Got it.
So let me share my screen. I think I have to. All right, maybe I'll just. Okay. So make sure you have the topology. Otherwise, maybe take a snapshot of it. Okay, I'll just clear this thing. Just give me 1 minute, guys. Yeah, can everyone confirm if you can hear me?
Yeah, Aniket, we can hear you.
Okay, thanks. All right. All right, and my screen is visible.
Yeah, it is.
So make sure you have this topology. So I have this host one that is connected to leaf one, and this is the sender. Okay. So this host one is going to be the sender here. And before we send anything, we'll just look into some of the states. So here on S1 leaf one, first look into the vextran config. Okay, what are the different things we have? Let me just clean this bit. I'll remove this one. Okay. So if you look into this vextran config, other than the VLAN 100 VNI, I also have something called as VLAN 100 multicast group. Okay. So this is necessary for this leaf one to encapsulate the traffic. Otherwise, it can't encapsulate. And as soon as you give this command, it will create the SPMSA AD route. So show. Okay, so if you see, this is a SPMSA AD route that is generated by this leaf, and you can see that it is star comma star, which means for any multicast group. Okay, for any multicast group, I'm going to encapsulate the feed with this info with this IP, and this is where in this is an extended community where you have PIM tunnel and you have the VNI, and this is the SG information that is present. 1111 is the VTEP IP of this leaf. So this is what you see here: 1111 225.111. Okay. And if you see for leaf 4, the VTEP IP is 4444. So this is what you see from leaf 4. So this is generated as soon as you give the VLAN 100 this command. All right. The next command that you need to see is under BGP. I have the MacVerb VLAN 100. We need to. So this is more on the receiver side. Okay. So on this leaf 4, where the receiver is connected, I should have this command redistribute IGMP. Why is this command needed?
To generate the SMET route.
Yes. So without this command, SMET will not be generated. All right. Okay. And one more command which is specific to multicast, we need SFE forwarding, SFE, software forwarding, SFE. So this is also we need for this to work. So this is taken care by the SFE engine, I think. So this is something we'll check later, but I'm just highlighting here because this command is needed. Okay. Other than that, here also, if you see on leaf 4, although this has a receiver connected, but I also gave this command here. That is in case if I connect a sender on this leaf 4. If I don't plan to connect a sender, I might as well just remove this. Okay. And it's the same group, but because the VTEP IP is different, it is 4444, right? So this is why it is not a conflict. It's unique. Is that clear? Any question, especially for Mani, Ganesh, guys?
It's clear so far, Aniket.
I'm good, Ankit. Yeah.
Okay. Let me just pick this.
Can you also check show IP mroute just to make sure that entering
I'll
multicast
show you the
forms
mroute.
just after configuring, yeah, or after.
Yeah, I'll show the mroute. So yeah, I was going to go there. So if you see mroute, this whenever you do show IP, let me clear this. Clear IP. So right now there is no mroute. Okay. What I'll do is I'll send a IGMP report from the host that is connected behind leaf 4. So I have this host 2, which is the receiver connected behind leaf 4, and I'll send the IGMP join. Okay. And before that, let me show you here on leaf 1. where the sender is connected. So show BGP VPN route type SMET. I don't have any SMET route. That is pretty much expected, right?
Yes.
Now let me send the join. When I send the join, let's see what happens on leaf 4. First thing is I'll have a snooping entry where the host is connected, right? And then it will immediately join the underlay tree. Okay, this is leaf 1's VTEP IP. So it has joined the underlay tree of leaf 1. Now remember, this guy, leaf 4 doesn't know where the source exists. So there could be other leaf also, like leaf 3, leaf 5, leaf 6, which also advertise its own underlay SMSA type 10 route, right? So if there was other leaf also, it will join all the trees, because this doesn't know where the source is connected right now. Okay, so if there was another VTEP leaf 3, then you will see 3333 also, because it will try to join everything, considering it doesn't know where the source is. So it joins this tree, and if I see the detail, it is sent a upstream join. Where did it send? It sent it to via Ethernet 2. On Ethernet 2, the spine is connected. Now let's see on spine.
So the ET2 is it's determined by the RPF check for the VTEP IP, source VTEP.
Yes, correct. So on the where is leaf? Leaf 4, right? Yeah. So if you see, if this is where it's showing the RPF route. Okay. So for 1111, the route is pointing 14112, which is going to spine. Okay. So based on that, it is sending the SG join for the underlay tree. And on the spine, once it has received the PIM join, the IF will be Ethernet 2, which is pointing to leaf 4. Sorry, which is pointing to leaf 1, because that is where the source is connected. So it's going to receive the feed on Ethernet 2, but the OIL is Ethernet 5, which is leaf 4, because the feed is going out of leaf 4. Okay, so what we're seeing here is that when this join is sent here, it sends a SG join, and we see the OIL is pointing here, and the IF is pointing here. So it will receive the feed from here, and it will send it out like this. Okay. So this part is clear.
Yes, Aniket.
And if you see the spine M route, if you see the spine M route, you will see that it has joined upstream join. And where did it send the join? It sent it to, based on the RPF check, it has sent it to Ethernet 2, which is going to leaf 1. That is how the underlay tree is formed. Okay, so on leaf 1, if you see, now it has the M route.
I think if, as we discussed, right, if in this scenario we have just two leaves, if we have leaf 3 also, so in spine we will see two routes, right?
Yeah, that is because then the leaf 4 will send SG join for both the VTEPs, right? It will send it for leaf 1 and leaf 3. So then here you will see 225.111, one will be 1111, another will be 3333.
Yeah.
Yeah, because the leaf 4 is going to send the join for all those VTEPs.
Correct. Okay. Yeah, thank you.
Right, now on leaf 4, we have received the join from the spine, which is why you see, sorry, leaf 1, my bad. So on leaf 1, it has received the join from spine. So that's why you see the OIL as Ethernet 2, which is going to spine. Okay, so it will receive the feed from host and it will encapsulate. And after the encapsulation, it will send it out of Ethernet 2 towards the spine. And the IF is loopback 1, which is basically like encapsulated traffic. For any encapsulated traffic, IF is loopback 1. Okay, now if you see the snooping table, you will see for 100, 239 is this member is PIM tunnel, which is remote receiver. Got it? Okay, so that if this was not present, it will never encapsulate. So this has to be present for leaf 1 to start encapsulating, right? And this will be created based on SMET route. Now let's look into the SMET route. So if you see the SMET route, This is exactly how the report was sent by the host, *G, right? Because it's a version 2 report. And you will see that, yeah, exactly. This just has this information. And the next hop is 4444 leaf 4. That's all. Okay. So based on this M route, based on this EVPN route, it is creating the snooping table.
The overlay group, the actual group is 239.111 and the transport is just 225.
Yes. Okay. For VLAN 100, it is 225, but for other VLANs, it should be different. Okay. For every VLAN, the multicast group should be different. So here, if you see, for VLAN 100, I gave it this, but if I do VLAN 200, then I can't use this group. This is unique per VLAN. Right? Okay. Any question so far?
That multicast flag exclude, does it have any significance here?
Multicast flags exclude. I remember this. This has
It's
something
not
to do
says
with.
like anything leave or anything, right?
No. It's not for leave.
That's not okay.
I can check
Is
this
it
later.
that IGMP specific include or exclude?
Yeah, it is specific to IGMP only.
Okay.
Include and exclude. There was some. I think Sam had a case sometime back, right, with this include and exclude. Someone had a case.
Yeah.
But anyway, Sorry, Sam.
Yeah, I had a case with include and exclude.
What do you remember what was this exclude?
No, it was not over EVPN per se, but it was a simple multicast setup with include B. We have to.
I think it
was related to some timer. It was not specific to what source or anything.
Is it related to the version 3 or 2? Because in version 3, include goes and it tells what specific source is needed.
Version 3 has that
If
include
it is
exclude.
empty list means it can receive traffic from all sources, I guess.
But that flag, I think it's more about some flags, right? It said something like that.
It's a flag. I mean, here, as per Google, it says from whichever sources it doesn't want the traffic from. But that should be
version 3 stuff.
Version 3 stuff, yeah. So I don't know why we're seeing it here in Esmet.
Snooping detail, it has that filter mode, include, exclude. I think that was the case. Snooping detail, it has that include and exclude, and we might add filters to avoid certain sources, I guess.
That is in version 3, right? In version 2.
Yeah, this include and exclude is there.
Version 3, yeah.
So maybe when we're testing, we can send some source specific feed and see. That's all.
So right now,
like V3 join, you can.
Okay. Even V3 join.
Yeah, V3 report we can send. Right now also we can test.
No, we'll test this maybe next time. For now, let's go ahead. But yeah, but this is nothing specific to EVPN as such. Just very much IGMP specific. But we'll look into this later. Okay.
Okay.
Right now, if we have the estimate route, we'll create this snooping entry. Okay, and source is any. Right now, let me send some feed. Or am I already sending?
Question and in the source leaf that is encapsulating the traffic, how should it know that it has to encapsulate with this 225.111 and not some other? Is it based on the VLAN specific?
So that is because I mean that is what we have configured, right, for VLAN 100. So the sender is sending the feed in VLAN 100 only.
Okay.
So if it receives any feed in VLAN 100, and I think we have some command show, let's see, EVPN, no, not this. It shows the encapsulation. Okay, maybe IPv4. We have it in the TOI. One second. Basically, it will show you what is the encaps. Yeah, this one. Show multicast. Okay. So any overlays group or source, whatever that is, it is going to encap with this as a destination and this as a source. Okay, and that is because based on the configuration we have provided. Right. One thing now we need to understand, and maybe I'll create a new topology for that. One second. Okay, so all right, and the multicast group is 225.111 for VLAN 100. And let's say I have a sender here. In VLAN 100, everything is VLAN 100. Okay. So this was and I have a receiver. So one drawback that I just want to talk here, more of a design issue, you can say, specific to L2. So let's say this sender is sending the join. So sending the actually both the senders are sending the traffic. Let's say, okay, but they are not getting encapsulated. Why? Because the underlay tree is not formed yet. Now, when this when this receiver is going to send the IGMP report, this leaf will join the underlay tree for both 1111 and 3333. Okay, so that would mean even if maybe the intention was that the receiver should receive the traffic only from this sender 1. Let's say the intent here was to receive the traffic only from sender 1.
Shouldn't it be 222?
Sorry, yeah, 222. Yep. So the OIL will be IF will be spine, and OIL will be VLAN 100. So the problem here is that every source that is sending the traffic will be coming here. Okay. In fact,
got it. So will that be duplicate traffic then? Or not?
Yes, there will be duplicate traffic because this leaf 3 is just going to join the underlay tree for this, and it will receive this traffic. Now, that is for VLAN 100. But let's say even for VLAN 200, okay, so let's say this is VLAN 100, this is VLAN 200, okay. No, actually for VLAN 200, this issue will not happen because the estimate will be sent for VLAN 100, right?
Why we are saying it is a duplicate traffic? It will not be duplicate, right?
Duplicate in the sense like it will receive the feed from all the senders.
Yeah, but traffic will be unique from sender 1 and sender 2. Right?
It will be unique, correct. not duplicate, but
Okay, not duplicate, but it's basically for the same group.
Yeah, same
Receiving
feed.
traffic from multiple feeds.
Yeah.
So how to prevent
So
it?
that will happen. Yeah. Right. Yeah, that is. But there was one more scenario I'm just not able to recall right now. With a different VLAN, I'll try to think of it later. But okay, I'll think of that later maybe. But yeah, right now this leaf tree will never know who is the actual source. It will just join the underlay tree for all the leaves and it will get the feed from everywhere. Okay. So let's send some traffic. And actually, I'm already sending from host 1. So let's go to leaf 1. Let's leaf 1. Okay, maybe I need to open it. Okay, so let's see if I'm getting the feed or not. Show interface Ethernet 4. All right, I'm getting the feed. If I check them route for 225.111, the Ethernet, the OIL is Ethernet 2, right, which is going to spine. So if I take a capture on spine, so by the way, right now, any data plane traffic, it will not be seen on regular interface. Like it's due to the SFE engine, everything is programmed in virtual hardware, you can say. So if I just do TCP dump, so on the spine one, I should receive the feed from Ethernet 2, okay, where the sender is connected. So if I do TCP dump interface Ethernet 2, let's see if I see the feed. Oh, okay, we can see actually, I think. But what I'm going to show is we can also do mirroring here. So I've done mirroring, and this is what I'm trying to show here. Yeah, you can do mirror also. So if I do a TCP dump now, do TCP dump monitor test. Sorry, monitor from leaf 1. Leave a verbose. So if you see the feed, the outer IP. Wait a second. Is it getting flooded? It is getting flooded, right?
Right, the DMAC is not a multicast map.
Yeah, wait, something is.
I think we need to configure the query.
105.
Yeah, something is missing there. Because I made a lot of changes. I was also testing L3. Let's see.
I think on the sender VTEP, right? The flat.
This is fine. We need to check on source, please.
So sender VTEP is here. Yeah, sorry, Sai. What are you saying?
Yeah, on the sender VTEP.
Yeah.
Okay. It's for okay, my bad.
Yeah, Sudhamsh, go on.
Yeah, I think the flooding would be true on the sender bit if you do.
Oh, yeah, I think I need the
query configured.
Snooping query config, yeah. I thought I had configured that.
I was about to ask that question. Right? So,
yeah, maybe I don't think then I configured show run section. Yeah, okay. Good catch, Sudhamsh.
So what happens in absence of query here?
Yeah. Salil, you were saying something?
No, in absence of barrier, will the source leaf not still encapsulate the traffic in
In the absence of query, this flooding is true. See?
But,
and if you
this
see
is on the
snooping,
receiver side, right? Okay. No.
No, this is on the sender side.
Okay.
And snooping is false. So it'll not even look into the snooping table. It'll just flooding it.
Okay.
Okay, once we do that, Now let's see show IP IGMP snooping VLAN 100. Now flooding is false, snooping is true. Hopefully now it should not flood it. Let's see. It's fine. Yeah, now I believe, yeah, now it is underlay. Yeah, but I'm glad we ran into this issue because this showed the importance of query, right? So you have to configure. I believe I had configured on leaf 4, but maybe I forgot to do it. Yeah, I configured it here on leaf 4. I forgot to do it on leaf 1.
So one doubt here is, Aniket, so this query, right? So it should be configured locally on every VTEP, right? On
Yes.
sender VTEP.
On the sender VTEP, especially, yes. Actually, we should do it on the receiver VTEP also.
Okay.
Because if the receiver VTEP, if you don't do it on the receiver VTEP, right, then also snooping is false. If snooping is false, then after decapsulation, it will not look into the snooping table.
So unlike the normal multicast, right, where the query election happens, so here the IGMP packets, so won't they go across the VXLAN fabric to the other VTEP, and the query election stuff, does it happen, or?
No. This querier, I don't think that is flooded. Basically, it's no, it gets flooded, but the snooping agent, the IGMP agent, it doesn't snoop the query that is received on VXLAN interface.
Okay.
So if it doesn't snoop, then it can't do query election, and that is true for IGMP report also. If you receive IGMP report, we never snoop. That's why we can never have IGMP entry on VXLAN interface. That's a long like that issue has always been there.
Got it.
So we have to configure a static query.
And we can give any random IP address for the query.
Any random IP. That this IP doesn't have to exist. I just gave some random IP, but this IP actually doesn't exist. This is just to activate the query and nothing else. Yeah. And hopefully the host is also receiving. Let's see. So, yeah, it's getting the feed. Okay, so this was about layer 2. Pretty straightforward, I would say, but very much important. All this understanding of when is a SMET route generated, when is a SPMS AD route generated, these things should be very, very clear before we proceed. So I'll take a pause and open it for discussion. Any scenario that you want to test, any doubt you have about the setup. It's a very simple setup. No MLAG, no multi-homing, but we'll go each of those one by one. But with this setup, anything that you want to clarify about any of the route or concept?
One thing is when receiver is not present, and
Sorry?
the source is suppose receiver is not present, and its source is still source is sending the traffic, basically that feed. So in that case, still will it establish the underlay PIM tree?
No, right? If you see, if you don't have a receiver, then there is no report, there is no join.
No join. Okay.
It will never receive IGMP report,
no join,
right?
Then no estimate route.
If it doesn't have a report, then it will never join the underlay tree at all.
Mm-hmm.
And it will never create a estimate route.
I was just telling, what if it joined it for some other group? The underlay tree might always be there, right?
Yeah. Oh, this is what I was going to think of the other scenario. Yes, correct. Thanks. What I was going to say, let's say, I was trying too hard to think of it, but yeah, thanks, Prajola. So let's say you have two receivers, okay? Receiver 1 and receiver 2. Okay. Let's say receiver 2 never sent any any join. Let's say this receiver 2, it sent the join for, okay, 1 second, let me just think. So let's say this one send the join for 239.1.1.1. What was actually, wait, sorry, my bad. I'm still getting a bit confused. What was the scenario? I was thinking whenever this will send the join, it will receive the feed. But the thing is, if this receiver doesn't send the join, then the feed will actually not go here.
I guess, Aniket, just to elucidate, it's that scenario when source doesn't check what group the end receiver requested for. So in every case, the source will send to leaf 3 and leaf 3 has to decide whether
Yes.
it has to forward or not.
Yes. So, correct. Even for different.
Yeah, for different groups as well. Yes.
No, not for different groups, right? Because see, the PIM tunnel is here. If you see on S1 leaf 1, right? This is specific to the group. So if the estimate route is sent for 239.111, it will not going to encapsulate for something else like 239.222.
Okay. Got it.
Yeah, so there is something that I'm not able to recall, but I'll think of it. Either with multiple receiver or multiple sender, there was a particular scenario that is there.
So let's say, Aniket, we have some other leaf who requested feed for that 239 group. Okay, but the spine has the complete underlay tree constructed because, okay, let's say leaf 3 is requesting feed for 239.111. Okay, leaf 2 does not. Leaf 2 receiver does not want feed. But leaf 2 has the underlay SG constructed because it's requesting feed, let's say, for some other group. Okay, basically the point is underlay tree is constructed and spine.
Correct.
I think that is the.
Yeah, correct. Yeah, thanks. Yes, exactly. So let's say this is a receiver, and let's say this receiver is requesting for a feed from 239.222, right? Yeah, thanks, Prajwala. This is exactly it. This is the one.
No problem, Aniket.
Yeah. So when this receiver is going to send a IGMP report, and let's say this receiver is sending the report for 239.111, right? So both leaf 3 and leaf 2, they will join the underlay tree. Okay. So how will the MRoute look like here? If we do show IPM route for 225.111, which is leaf 1, you will see the IF as leaf 1 interface, and OIL will be leaf 2, leaf 3 interface. Okay. So this is a problem here, that although this receiver is requesting the feed for 239.222, but when this sender will sending the, let's say there are two sender, right? One is sending, actually it's fine. Maybe this sender is sending the feed for both 239.111 and 239.222. So when this feed will go, it will get encapsulated and the feed will reach here. The encapsulated feed will reach here, and both the feed will go on both the devices. Okay, so the feed that is destined to 239.111, that will also receive, that will also reach leaf 2, for which there is no receiver. Okay, and here there is no receiver for 239.222. Still that feed will reach here. It will be dropped here because there is no entry in the snooping table, but at least this feed will reach here. Yeah, that's the scenario here.
But that is total waste of bandwidth, right? Lot
Total waste
actually.
of bandwidth, right? Yeah, I mean, long time back only, I had raised this, but it's like, I mean, during I think EVPN training, like ACE training, that time the trainer was like, this is how it is, the design. But yeah, it's a waste. Like there's no way the spine can distinguish that there is a receiver for 239.222 pointing here. There's no way the spine will ever know. It will
Correct.
just see the underlay tree and it will send it here and here.
True.
maybe the only way to avoid this kind of flooding is, give a more specific underlay groups for each group on the sender side.
Yeah, but then there could be many overlay groups, right? We never know what.
Right.
Yeah, I mean, if you can know what groups are there, then possibly yes, but there can be thousands of multicast group. I don't know how.
Yeah.
Or somehow spine should have a record of something similar to snooping table. So based on that, it can send.
Yeah, and at the end, the spine can only do mroute lookup. So how after it does mroute lookup, how can it do lookup for the overlay?
No, maybe a new type, something like that. We have to introduce.
Yeah, we have to completely think of the design then.
Design, yeah.
Because then the spine should, if the spine is doing only underlay route, then we can never resolve this problem.
Never. Makes sense. Thanks, Anik.
In one of my cases, the middle leaf, the leaf 2, just received a join for a non-existing group. And even in that scenario, the traffic for the existing group, 239.1.1.1, started reaching leaf 2, and it was later dropped by GMP snooping.
Yeah, this is the exact problem then, right?
Right. Yeah.
Yeah. I remember just discussing with you also.
Right.
Anyway. Okay, any other questions?
Where do we, just
Okay.
one kind of basic question. So this underlay group we form, right? That's the SSM address. 232 is the SSM address, but it's not like mandatory. It's like any arbitrary value can also be added right in the underlay. Just want to confirm.
239.222 is for the overlay. Okay, so you have to understand.
225, it's not the SSM range, but it's okay, right? Because in the guide it's mentioned 232, but still, and it doesn't have any impact kind of thing, right?
Yeah, because see, SSM there is there specific group, and that is mostly needed for version 3 IGMP report. But here the concept here is that we are not necessarily using any version 3 report or anything. We are just. You can say that it is actually not SSM. It's just there is no need for RP here because the source and the like everyone will know who the source is because of the EVPN.
Yeah, well, it's not mandatory to have anything like 232. It's like anything can.
No.
Yeah.
As I'm saying, yeah, that's what. This is not exactly SSM, but it does the job similar to SSM. You can say that way.
Okay.
I think we shouldn't be calling it as SSM. A lot of them are getting confused.
Yeah, this is
It's
not SSM as such. It's just the design is how it is. Based on the implementation, there is no need for RP because we always discover the source VTEP. And if you see this, yeah, and if you see this IMET route, you will see there are two IMET routes. So this is on leaf 1. So one IMET route is for the flood list. We use this IMET route to create the flood list, but there is one more which used for snooping. Which has a flag IGMP proxy. Okay. So and if I use OISM and all those things, then you will see the flag as OISM, SBT, all those things will also appear here. But this is just layer 2, so you will see IGMP proxy here. Which means like this device is capable to send SMET route. Yeah, it's doing a proxy. If it receives a IGMP report, it can create a SMET route. That's all this route means, this flag means. Oh yeah. And because of the SPMSAE route, we know the exact source. Okay, because we have the SPMSAE route, we know what is the source 1111. So this is not exactly SSM, but we know the source. Okay.
Recently, I had like worked on case where the source was not directly connected to the sender VTEP, but there was some PIM router in between.
That is a PEG concept, Salil.
Yeah, correct. But that feature, right? It's basically used to convert those SMET routes into IGMP joins on the source VTEP.
Yeah, I mean that is a complete different topic. That will go into the depth of it.
Yeah.
Which is PEG and all.
That was again L2 EVPN.
So you had the source connected on a different PIM domain or receiver? Which one?
Source was connected on a different PIM domain.
Yeah,
So,
then okay.
Yeah, but
Yeah,
still
then
it was L2
that
EVPN
router
only.
will be the PEG. So when that PEG router will receive the SMET route, it will send if that is a PEG DR, that will send out a SG join towards a external domain.
So the scenario was there was one layer 2 switch connected to the source, and from that layer 2 switch there was another like L3 router between the source and that switch. So what the behavior was when the source VTEP received this SMET route, it was supposed to send an IGMP join towards that leaf.
Okay.
Usually we don't do that in normal scenario. So for that we have some special config enabled like IGMP proxy, where the source can convert those SMET routes into IGMP joins and send it upstream. So that is again a corner case.
Yeah, so what we are planning is after the end of all the sessions, we will be discussing all these cases that we have. So we also had one more very interesting case which Raja was working on. That has to do with PEG transit gateway. And then I remember Sudhamsh and Ganesh, they also had an interesting case with the multicast. So we'll be discussing all those scenarios, and probably we'll try to see it in lab also. Okay, and make sure you keep a list of those cases. We'll try to discuss each of one of them by the end of these sessions.
Okay. And one last query. So do we also have this basically Anycast concept here? Means all the VTEPs have the same VXLAN IP address.
Anycast RP?
Not RP. It's Anycast means views is right, a virtual VTEP. So all these VTEPs will be configured to the same VXLAN IP address.
No, I'm not getting you. Are you talking about the overlay SVI, IP address virtual, or what are you talking about?
MLAG.
No, under VXLAN, right? We have this source loopback as loopback one, what we define. And in case of Anycast, will all those that loopback IPs will be same on all the leaf VTEPs.
Are you talking about MLAG or what?
No.
In MLAG, the multicast, I mean the VXLAN loopback IP will be same, but the multicast loopback will be different. So we have to configure two loopback IPs over there. So that is for the MLAG.
Okay.
No, I think Salil is talking about VVTEP.
Yeah, VVTEP. Basically, Anycast means
yeah.
All the
VVTEP has nothing to do with multicast. Now that is completely whatever way the unicast works, that is not changing here. So you can have IP address virtual MAC, VVTEP, everything could be present here, and that is independent of how EVPN multicast is working. So VVTEP is not going to play a role in EVPN multicast here, and that will never work also.
Okay.
Because here the idea is that all the SG has to be unique, for the underlay, right? So if you use same IP, then you can never have a unique SG.
Right.
Yeah, just one scenario I found that one customer was sending the same two different streams with the different ports with the same IP multicast source group. It was like weird, but I thought it was that was That was one thing. It would have some duplications, or the scenario which you mentioned would also come into clash, I guess, right? But I don't see that very often. But it was one weird guy doing it with the same group with two different streams with segregating based on the port group.
You mean the sender IP was same? The
No,
source IP?
the multicast group, yeah, same source IP. Multicast feed, they differentiated with the.
What is then? That is just duplication, right? Why? What is the need of that?
No, it's two different streams actually. The receiver will segregate
okay.
based on the port.
Okay.
It was one weird. I don't know if nobody uses that. I hope so. But I found this will also include that scenario which you mentioned, where it will also the uninterested receivers will also receive.
Yeah, then even the receiver that is interested in that, let's say 239.111, it'll receive both the stream, right? Because the group is same. So this receiver one will receive both the stream.
It will receive it. Okay, got it.
Yeah.
I think that thing which Raja said, I think few of the trading customers use it for things like feed A and feed B, where they have same group but different ports, something like that.
Yeah, and I think that is fine, right? I mean, I don't know. You can have one sender which is sending multicast stream, different multicast stream, right? Let's say you have this sender which is streaming multicast, different type of multicast feed. So it's possible. So for different stream, you have the same source IP. And but yeah, the group IP is something, I guess, questionable. I guess different streams should use different groups, but if all the streams are using the same group, I don't know, maybe that is what Sudhamsh is saying here.
Right. Yeah. And also, Aniket, I was going through the Sandhya sent to multicast document. So there was a mention of differentiation between BUM and bull traffic.
Oh yeah.
Is that required?
Yeah, let's actually, while we have time, we'll talk about that. Yep, thanks. So yes. So right now, whatever we are talking here in whatever we discussed so far has only to do with the multicast traffic, which is non-link local. Okay, can anyone tell what are the link local group?
224.0.0/24.
Yeah. So like OSPF 225.0.0.5, right? So those are all link local. But this is this group that we create here, this is for non-link local. Okay, but what happens for link local packets, or what happens for broadcast packet? Now these are two different things. If you receive a broadcast, then it will just use a regular flood list that you have. Okay, and if you receive a link local packet for which this leaf is not listening to, okay, I mean, let's say you're not running OSPF here, okay, so it can flood the link local. So that should also not use this one. I believe that should use that also be using the flood list. So for link local, for bull traffic, which is broadcast, under unicast, and link local, we can create another group. So VXLAN, VLAN 100, flood, and you can see group here. So I can say 228.1.1.1. Okay. When you do this, the replication will be earlier. If you see the flood IMET route, I don't know if I have it here. Okay, maybe first remove this once. Yeah. So here you will see the replication is ingress replication, which is based on flood list. Okay, the PMSI tunnel says ingress replication, but when we give that VXLAN flood group command, then it won't be ingress replication anymore. Oh, wow. Really? Okay.
Top VLAN 100.
We created, yeah, this one, right?
Yeah, that's
This one. So we are actually you are sending both the route ingress replication because it can do ingress replication also, but we are sending the IMET with this information also.
The second
Okay.
one is VLAN 200. You had said the flood group would be for VLAN 100.
Yeah, correct. This is for VLAN 200. Yeah, that's what I was thinking. It should not be. So for VNI 100, this is the replication. Okay, and when we when the receiving VTEP leaf 4, when it will receive this route, yeah, so it will immediately join this group unless I guess we have to do it on both sides. This is one and this one. Okay, let's see, show. So this should immediately join this tree. Yeah, now it has joined. Why is it joining this tree immediately?
Because it has to flood to other VTEPs as soon as it receives bull traffic.
Yeah, because bump traffic can be received anytime. You don't know that, right? So it should all like this leaf should always be prepared to receive any bump traffic that you receive from here, not bump, bull traffic that you can receive. So it will always join this tree, the flood group. Okay, and similarly, leaf 1 is always joining the underlay tree for leaf 2 for the bull. Okay, so let's see here on leaf 1. Yeah, so here also it has joined for 4444. So anytime leaf 4 is going to flood any bull traffic, leaf 1 is prepared to receive it. Okay, so now instead of flood list, it is going to use this. If I send, let's say, if I send a broadcast, let's see how it looks like. So I'll send a broadcast from host 1. So I'll just ping some random IP 10.1.1.100. And if I go to spine, purpose. Yeah, you can see, right? So this is the ARP request that is coming from host 1. And now that ARP request is now encapsulated with this flood group. Okay. If I remove that flood group, then it will be, you will see 4444 here. Is that clear? Bull traffic. Similarly, for as it says, for this is true for broadcast, unknown unicast, and link local. Link local that needs to be flooded. If the link local is understandable by the leaf, then it will consume it. But if it has to flood, then it will use this.
So this is like preventing the bandwidth choking between the leaf and spine, right? So you are not doing HCR at the center.
Correct. But like eventually all leaf will be joining this tree, right? So this feed will be going, like if I go to the diagram, the flood group will be joined by all the trees. So either way, this whatever leaf is encapsulating, it will go to all the leaf.
But the replication would be at the spine.
Correct. Replication is happening on the spine. Yeah. So leaf 1 here the bandwidth will be saved. Correct. Yeah. Because leaf 1 is not replicating it. Yeah.
So all the leaves in the VXN fabric should join that multicast group which we gave, right? If not,
correct,
there would be some issues. Understand?
Yes. So there could be the thing is if it, I mean, there could be some VTEP that doesn't support EVPN L2 multicast. So they should receive the feed via regular flooding. So I think that depends. Like leaf one has to receive the IMET route from leaf two, stating that it supports it supports flood groups. So only then leaf one is encapsulating it. That's why you are not seeing the M route also being populated. So, but let's say leaf three doesn't support EVPN L2 multicast. It needs the traffic based on flooding. So this is in its IMET route, there will be no tunnel ID as 228.111. So for that, leaf one should be able to flood it also. So that should reach leaf three, because it should be working with other vendors or any other hardware that doesn't support EVPN multicast.
Okay, understood.
So you're telling it will do both HGR and also this.
Yeah, I think so. I'll test this probably, because I remember vaguely that it should be working with other vendors that doesn't support EVPN multicast. So if this leaf 3 doesn't send the IMET route stating that the PMSA tunnel is not 228.111, then it can't understand. I mean, it is not going to join the PIM tree here, right? So how will it leaf 3 is going to receive the feed? For that, it should be flooded.
So, but that will send it only to leaf 3 or
only to
is
leaf
it intelligent?
only to leaf
Only
3. The flood list, only in the flood list you should have only 333.
Hey, Aniket, can you go to leaf 1 and just do show in 2x1 just to check the flood list?
Yeah, correct. I think flood list will be there.
Okay.
Oh no, yeah, flood list is. Oh no, that's for VLAN 200. Yeah, it's not there. Correct. If I just remove this, just for example, let's say, if I remove this, then it will appear. So leaf 1 now knows that leaf 4 doesn't support flood group, right? So it should. Okay, wow. Why is it? Not sure if this is expected. I was hoping I should see for VLAN 100 also.
Can you check the IMET route that is received on?
Yeah, it'll not have the PMSA tunnel one, 228. Let's see. Detail 44, right? You just have the IGMP proxy. Oh, it has this. Oh,
Maybe clear.
Oh, I removed it. I removed it from here. Is it from leaf 1? Yeah, I removed it from leaf 1.
Oh, okay. Can we check on leaf 4?
Yeah. Leaf 4. I don't know why it keeps spawning a same device. Leaf 4 was open, but it became leaf 1 somehow. Weird. Yeah. Okay. Because now when leaf 4 is receiving the IMET from leaf 1, it will show EVPN route. So when it is receiving from leaf 1, 1111, you don't have 228 here in the tunnel ID, right? So if it doesn't have that, then leaf 4 knows that leaf 1 is not going to join the underlay tree for bull traffic. So it has to add it in the flood list here. But if you see on leaf 1, you have it. On leaf 1, if you see you don't have this, because it knows that leaf 4 is going to join the underlay tree. So whatever leaf 4 is sending, it has this tunnel ID.
So in this particular case, if you receive any bull traffic on leaf 1, it will miss the multicast group. But if anything is received on leaf 4, it will head and replicate.
Yeah, correct.
In our setup, right?
Yeah. So let's say I remove from leaf 1, right? So leaf 1 will not join the underlay tree for bull traffic. So leaf 1, if all like leaf 2 and leaf 4, they should program the flood list for leaf 1. So over here in the flood list, I will see 1111 for VLAN 100. Okay, because leaf 1 doesn't understand flood group, right? But leaf 2 and leaf 4, they have joined the, they understand the tunnel ID. Like here we have configured. So in that case, whatever this leaf 1 is encapsulating it, they can receive. So here you will not have flood list. You will not have a flood list for 4444. Because now whatever leaf 1 is encapsulating, whatever bull traffic it is encapsulating, leaf 4 can receive it. Yeah. That makes sense. I don't know if I confused.
Just to add on, Aniket, so not trying to drive us, but let's say leaf 1 is the source here, and you have the flood group as 225.111, let's say, which means all bull traffic will be sent via that tunnel ID 255.111, right? Let's say leaf 2 joins it because it supports it, but leaf 4 doesn't.
Let's use the flood group as 228. Okay.
Okay, sure.
Yeah. Yeah.
Okay, and let's say leaf 2 is supporting the tunnel, so it will join the underlay group and all. It works fine. But let's say leaf 4 doesn't support it.
Yeah.
Then I guess we have to explicitly configure flood list on leaf 1, telling that leaf 4 is part of the flood list. So in that case, it's a hybrid.
No, but see, this is if you see on leaf 1, I mean, yeah, here we have only 2 VTEPs. Probably I can check it with multiple. But if you see on leaf 4, that's exactly what we see, right? On leaf 4.
VTEP 4, I think.
VTEP 4, you have the flood list because leaf 1, the IMET route from leaf 1, it doesn't have the tunnel ID 228.
Okay.
Okay. So it is adding it in the flood list here.
Okay. Okay.
Now, when leaf 4 is sending the tunnel ID 228.111, because of which on leaf 1, we see that we don't see the flood list for VLAN 100. Okay, so here it has joined the group.
Okay, got it.
For 444, yeah.
Okay, so it will automatically take the flood list from the IMET type they already received, and we don't have to do any change. Okay, got it.
Because it knows who is sending the IMET and whether they support, whether they understand flood group or not. Based on that, it will create the flood list.
Got it. Makes sense.
Aniket, I just have one doubt. So let's say we have a what do you snooping entry, local snooping entry also, and okay, let's say we have a sender connected on the same leaf, right? So that time also, anyways, this EVPN stuff, the encap and the tree building, everything happens. So let's say we have another sender with a different IP. Okay, here leaf 1 has one sender. Okay. Okay, and leaf 4 has one receiver, right? Let's say it has a sender also.
Okay. Okay.
Okay. If it has a sender, let's say 2111 something. Now, the sender, now the receiver 2 will receive duplicate feed, right? I mean, with different sources, but it'll receive duplicate
for the
feed,
same
isn't it?
group, you mean? For the same group.
For the same group, correct.
239.
Both the senders send traffic for the same group, yeah.
Yeah, if it is a version 2 report, then yes. Because it will send the report, it will send a version 2 report. So it will be for any source, right? So it will get the feed from this sender also, and also from VPN. So that will happen. Yeah. And that is the point of, because it could be any source, right? So anyone, local or remote, whatever that is, it should receive the feed from any source.
Correct.
But will it not happen like I think in while SPT selection, right? It will select the source which is closest, which has the lowest metric, maybe.
No, why lowest metric?
In
source could be anything, right?
when
it
we
could
were
be.
having, yeah, please go ahead.
Yeah, no, I was saying like in your snooping table, you will see star, right? Star, comma, and the snooping table will be 239. Like the group will be 239. So whatever is the source, no matter whether it is local or remote, it should send the feed to the receiver.
Okay,
Got
okay,
it.
okay, got it.
In this particular case, how would the M route look on the spine? Would it be?
So M route will be 225.111, comma 1111. IF will be leaf 1, OL will be leaf 4. That's it.
But you would also have one from leaf 4, right? Because there is a sender there also.
Yeah, but that depends if there is a receiver that is present here who is sending a join. You have a receiver. Now, if I add a receiver here, receiver 3, if this receiver sends a IGMP report, let's say it sends a report for 239.111, right? Then this leaf 1 will immediately join the underlay tree for leaf 4 and also leaf 2, right? So then you will have another entry similar to this with IPS 4444 and IF will be leaf.
Okay, so if the sender and receiver are connected on the same leaf, then we expect the local tables to do it, and you wouldn't have anything related to EVPN working there.
Repeat that.
So if the sender and receiver are connected to the same leaf. So in this particular example, sender 1 and receive 2 are connected on leaf 4, right? So say we have just that. Then on your spine in the M route, you wouldn't see anything from leaf 4.
No, this M route is created based on the receiving VTEP because the receiving VTEP has to join the underlay tree. So if you have a, you are saying
both of them are connected on same leaf.
Okay. So this receiver is going to send the join. No, but it will not send a join for itself, right? It can't send a SGJ because your route to source, which is 4444, is my own IP. So it can't send a join to spine.
Okay, got it.
But will estimate?
But validated thing is when this leaf 4 will receive the join, the report, based on that, will it not create estimate route?
It will create estimate. Definitely it will create estimate because this receiver might be expecting feed from this sender also.
Correct.
So it will generate estimate. Okay. But what I'm saying is this leaf 4 will not join its own tree. It won't join its own IP. That will not happen. So it will join leaf 2 and leaf 1, but it will not join itself.
Correct. So that entry in spine is based on that SP MSI route, right? When it sends
no, this entry is based on the SG join that is coming from the leaves. So in this case, when receiver 2 sends IGMP report, it will generate a estimate route and it will send a SG join for leaf 1 and leaf 2. So that's what you see here, 225.111, 444, right? So this is created because leaf 4 sent a join for this group. But it will not send a join for itself. This join, this M route you see, that is because leaf 1 sent a join for 111. Because you have a receiver here.
Okay.
That Kirti, is it clear?
Yes, clear. Thank you.
Yeah. So the bottom line is anytime leaf will receive a IGMP report, it will create a estimate and it will join the underlay tree of other remote VTEPs, not itself. Okay. So whatever VTEPs has sent the estimate route, it will join those trees. All right, I think we are 6 minutes ahead. Any other questions, guys? Is this clear, this entire flow? I mean, this was not a proper presentation as such. I initially wanted to have this as a discussion only, so I never planned to make it like a proper training with slides and all. But yeah, I hope this is kind of clear, because the next one we'll do is with different VLANs, sender in different VLAN, receiver in different VLAN. We'll do that. Yep. Any other question? Okay, I'll stop.